All right, so for 1.6, our special functions, we are going to write in graph piecewise defined functions, okay, which are just pieces of different functions put together. And then we're graphing absolute value functions, which you did in Algebra 1. And then we're going to identify the domain and range for piecewise and absolute value using this set builder notation here. Okay, so when you're graphing each function, when you're doing this in your textbook, it's going to say the only key features you will need are it'll say to analyze key features, and the only one you have to write down is going to be the domain and range. All right, so we already got started with this part. So if you have f of x equals 2x and 4, these are two separate functions that you can analyze. These are your key values that you have to put on your table. Okay, so if this says x is less than 1, then we're going to choose other numbers that are less than 1 to put on our table, and that's going to help us find what our graph is. So it doesn't matter how many you do, you really just want to span your graph, and we have our straight edge, so that's going to be simple for us to do. And then when you plugged in 1, you should have got 2. When you plug in 0, you get 0. When you plug in -1 for x, you get -2. When you plug in -2, you get -4. Now, if you look here, this was a less than symbol. So when we graph this, this is going to be an open circle on our graph. And it's because of this symbol. This symbol means you are going to have an open circle on the graph. And it's only going to be for this point. Okay, so the point 1, 2 is going to have an open circle there. None of these are open circles. They're just points. So I have a point at 0, 0. I have a point at -1, -2. And then a point at -2, -4. And then that's going to keep going to the left because it's less than. This is where we're going to take our straight edge that we are using responsibly today. And we are going to be drawing that on there. And then make sure you put the arrow. Okay, the arrow is going to the left. One thing I do sometimes as well is I draw just a little sketch of what my graph is going to look like. So if it's 2x, it's a positive slope. That means it's a line going up from left to right. So I can see it has that shape, that same shape. That way, if it's a negative, I can make sure it's going in the right direction. Okay, now when you plug in 1, you're just going to get 4. And it doesn't matter what you plug in. So if x is greater than or equal to 1, if you plug in 2, you're going to get 4. If you plug in 3, you're going to get 4. If you plug in 10, you're going to get 4. Okay, so this is a closed circle. And it's only these key values where we denote what kind of circle it is. Okay, the rest are just points on your graph. But key things are happening at this interval, bless you, which is why we want to make sure we notate them. So you don't have to make these like as large as the other ones are, you can. And really, this is a horizontal line. So once you know that it's a horizontal line, you might not even need to put those in your table in order to graph it. Okay, but we are going to write down these tables so that we know what our key values are. Okay, so we have x is less than 1 and x is greater than or equal to 1. Those are our key values. Now, before we do the domain and range, some of you may have been wondering, if x is less than 1, why did we even start with 1? Why didn't we just start with 0? If you started with 0, then your first point would be here. You see how you would be missing that entire region of points? So if you just started here, you'd be missing all of those, and there's an infinite amount of points in between them, which is why you have to use the open circle. Because it's not just whole numbers, there are decimals too. We have to make sure that we represent those. Okay, and then with our domain, we're just going to be looking at our x values. Okay, so my lowest x value is negative infinity. And then I'm here, and even though there's an open circle here, the closed circle means there's no gap and it just continues to the right. So this is going to be all real numbers of the domain. Okay, I want to give you guys a chance to do the range. Okay, this is something that we were working on last week. And again, we're going to write it in set builder notation. Okay, so your lowest value, and remember, you always start with your lowest value, and I write it here because it's up and down, is negative infinity, and it goes all the way up to this point, right? So on the y, that's a 2, and then there's a gap here, and it picks up again at 4. Okay, so this part, because it's an open circle, is y is less than 2. Okay, y is less than 2, not less than equal to, because you have an open circle, or it's equal to 4, so we're just going to say or y equals 4. So y is less than 2, or y is equal to 4. All right, so for B, we are going to start by looking at these key points. So x is less than or equal to negative 2, it's between 0 and 2, or it's greater than 3. So remember, this is split up into 3 intervals. It's either g of x is x minus 3, g of x is equal to negative x, or you can have g of x is equal to 4. Okay, so we are going to put our key values on our tables. And then I like to write down, like, if it's a closed circle or an open circle, so I don't have to, if my eyes go back and forth from here to here, I like to just graph it from this. Okay, so the equal to means I'm going to have a closed circle at the key value of negative 2. And if x is less than that, then I just do 2 values that are less than that. It doesn't matter what they are as long as they're less than negative 2. Okay, and then here, it starts at 0, it ends at 2, and these are both going to be open circles because they both do not have the equal to symbol. And then if there are numbers in between, I like to do them, so 0 and 2 in between would be 1. And then the last one is 3. This is going to be a closed circle, and really this is going to be a horizontal line, so sometimes I'll just do 1, sometimes I'll do 2, just for my graph to make sure. Okay, so then let's plug it in and find our y. So we're plugging it into each g of x. So in this one, negative 2 minus 3, negative 5. Negative 3 minus 3, negative 4 minus 3. Okay, and then negative 0 is just 0. And then I have negative 1, negative 2. And then if it's a straight line, those are all going to be 4. Okay, so I'm going to have a closed circle at negative 2, negative 5. So I'm going to plot that. And then remember, the rest of these are just points. So I don't need to make them large. I just want to know what is happening. And you can see that This line is going down 1 over 1. Okay, the slope is 1, so that makes sense. So we're just going to draw our line. This is a positive slope, so it is going up from left to right, so that matches. Okay, and then I need an open circle at 0, 0. So I'm going to make that open. At 2, negative 2, I'm also going to make that open. You do not make the middle one open, okay? It's only the key values. So 1, negative 1 is just a point, okay? You can also just connect those together. The only time you'll have like the open and closed is if it's a key value. So you have 1, 2, 3, 4 key values that you have on there. Everything else is just a normal point there. And then again, once you know this is a horizontal line, don't feel like you have to like put the actual points there. We know this is going to be going to the left. Okay, now the domain for this is going to have 1, 2, 3 different parts because you have 3 different gaps. Let's see if you can do the 3 different parts. You're going to connect them with an OR. Okay, so the lowest x value is negative infinity, and I will like write it across the bottom, and then it goes to negative 2, and because it's a closed circle, you're going to have an equal to, so this is going to be x is less than or equal to negative 2, or it's in between 0 and 2. So if 0 is less than x, which is less than 2, or it picks back up here at 3, and it goes to positive infinity. So x is greater than or equal to 3. Is there anything you guys noticed about this domain? It is long. It's the same as what? Yeah, it's the same as what you have here. So if none of these overlap, it is going to be the same as these. That did not happen here because these overlapped one another, right? There was no gap in between them, so that's why we didn't have those same intervals. Okay, and then for your range, I'm going to do something similar. So the lowest y value is negative infinity, and that's going to go to negative 5. So the way that we say that are all the points are less than or equal to negative 5. And then it's an equal to because you have a closed circle. Okay, and then we don't have any part of the line until we get to negative 2. And then we have this interval from negative 2 to 0. You are always going to put the lower number first. So it's a negative 2 is less than y, which is less than 0. And you're always using y if it is the range. Okay, or you're just here at y equals 4. Okay, now if you look at these values and you look at your table, -5 is your y, -2 is part of it, 0 is part of it, and so is 4. Okay, now in some rare cases, you can have an open circle and a closed circle overlap. Like one would be right on the other. If that happens, then the circle is going to be closed. Okay, so you don't, like, if you have a closed circle, you don't put the open circle around it. There's no targets. It would just be closed. Yeah, no target branches there. No bullseye. Okay, and then once you guys have that written down, I want you to read through the story problem in example 2 and just highlight your key parts there. All right, so in example 2, Tony is buying some ribbon, and I hope we highlighted the prices. Okay, so $8 per roll, $6 per roll, $4 per roll, and then they gave you the conditions, right? So if it's 4 or fewer, that's when it's $8, 6 or fewer, or $6 if 5 to 10 are purchased. And then if more than 10, it's going to be $4. So you are writing a piecewise defined function. So we're going to start it with f of x equals. We're going to make that one fancy bracket. Okay, so you're going to have several different cases, right? If we look at what we highlighted, we have 1, 2, 3 different cases. So we need an equation if. So I want you guys to work with your row, and I want you to come up with a equation. Or some of you already did, you can explain why you came up with that one. All right, so it looks like we did a good job with the x's in particular. So the first one, what is the lowest x value you could have?
Or 0.
0, yep. So it would be 0 is less than or equal to x, which is less than or equal to 4. Okay, so 4 or fewer. Okay, but you aren't going to have any negative rolls, so we're going to write it like this. Okay, okay, and then I'm going to be a little flexible on this symbol. So like if you guys put 0 and you didn't put included, I would not mark that wrong. Okay, and then for the next one, it's going to be between 5 and 10. So is that going to include 5 and 10?
Yeah.
Yes, so you got to have the equal to, and then more than 10. Is that going to include 10? No, so x would be greater than 10. Okay, and you don't want to have the equal to here if you have it here, because that means 2 equations are going to be for one thing, and we don't want that. Okay, so the most common equation that I've seen are either you have 8 or you have 8x. Okay, so this is how we can determine which one is correct. So we can think of values from here, right? If I bought 2 rolls, if I plugged in 2 here, it's saying 2 rolls would cost how much? 8. And here it would be 16. So which one's correct? Is 2 rolls going to be 8 or is 2 rolls going to be 16? 16. So if you just have 8, that's okay. We just need to put the x with it. There are cases where it might be a constant value, okay? And like sometimes if you're going to the post office, they charge a flat rate from a certain amount of ounces, right? This is per roll, so because it's per roll, we have to have the x in there. All right. Other questions for me on this?
For the x is greater than 10, how can you get the clarify?
Because it'll be positive, so technically it could go up to infinity, which is highly unlikely, but it is still possible. Yes. Okay, and then for B, it says, what's the cost of purchasing 3 rolls of ribbon? Okay, so if it's 3, you just have to find which one it falls into. It would fall into the first one, and really all I need to see in terms of work for that is 8 times 3. It would be $24. Okay, so you're just showing me how you got the answer. Okay, for 6 rolls, what would we multiply 6 by? Yes. So $6, because that's going to fall into the second one. Yeah. Good.
$36. What are these?
Rolls of ribbon. Okay, so the graphing absolute value functions, like I said, this is something that you've done before in Algebra 1. Okay, the reason why it's covered in this section is because you can write an absolute value function as a piecewise function. Okay, f of x equals the square root of x is called the parent function. Every function has its own family, and the simplest of the functions is called the parent function. So you may or may not remember that the absolute value is a V shape, and this point that it comes to is called the vertex. Okay, similar to a parabola where the vertex is either the highest point or the lowest point. So this parent function could be written as a piecewise. It's x if x is greater than or equal to 0. It's a negative x if x is less than 0. And the domain is going to be all real numbers. So we're going to continue to write that in set builder notation. So it's x such that x is an element in the real number set. And then your range is going to change based on your function. Okay, so your range says all non-negative numbers. So non-negative numbers are what type of numbers? Positive and what's another non-negative number? 0. And that's why they say non-negative instead of positive, is because they want you to include 0. Okay, so for this one, it would be all values of y such that y is greater than or equal to 0. As your function transforms, so is your range. Okay, so will your intercepts change. But for this one, the intercept of y and x is 0. Okay, so I want you to write down a few things that you remember about absolute functions, absolute value functions, from studying them before. What's something we remember? Give you a definition. Yeah, but whenever you do the absolute value, what do you guys remember about that? Yeah, it was always a positive value. Yeah, do you guys remember why they're not negative? What the definition is? Yeah, it's the distance from 0. So distance is going to be positive. Okay, so it's a positive value. It represents the distance from 0. So whether you're going to the left or whether you're going to the right, that distance is going to be positive. Okay, even if you didn't remember this, it is right in front of you. The shape of the graph is a V. Okay, it's either V-shaped or upside down if you have a reflection. Okay, it also is symmetric. Do you guys know what kind of symmetry it has? Line symmetry, yeah. So it's symmetric, has line symmetry. Okay. Now keep in mind, when you're graphing these, you are graphing one part of it, so one window. So it might not look symmetric in the window that we're graphing, but it is going to be symmetric if we extend it. Okay, and we'll look at that more in our first example. Okay, so we are going to be graphing transformations of this function. So a transformation can be a translation. Do you guys remember what that means, a translation? A slide. So move it up, down, left, right. Yeah, exactly. Slide to the right. Everybody clap their hands. I don't know. And then, yep, and there is a reflection, okay, and then rotations. There's also compressions and stretches, which you may or may not remember. So in order to graph this and see the best window we possibly can, the first thing we want to do is find the center of the graph. So to find the center, you always set the inside of the absolute value equal to 0 and solve, which is going to be fairly simple for this first one that we're doing. But as we get into more complex equations, I want you to make sure you understand you're only taking what's inside. Okay, this one only has something inside. So you may be thinking, why do I even have to write that down? Okay, you're going to have many different equations that you're going to have to be able to find the center of. So if I look at what's inside the absolute value, it's x minus 7. I set that equal to 0. I add 7 to both sides. X is 7. That's going to be my center. Okay, so then what we're going to do is we're going to create a table. When you create the table, you're going to put x equals 7, or whatever you got there. Okay, so you're going to put x equals 7 in the middle and go 2 units to either side. Okay, so see if you can do that. See if you can create your table with the 7 in the middle. What does it mean? There will be 2 units to either side. What else are we going to put in our x values? And then we can start to find our y. Or maybe he does it so people buy more. Or they'll buy more. Okay, so now I want you to check your table and make sure you put on the 5, 6, the 8, 9. right? So if I go 2 to the left, I'm going down. If I go 2 to the right, I'm going up. And then I'm just going to plug those in to find those. So if I do 5 minus 7, 5 minus 7 is negative 2. The absolute value of negative 2 is 2. Okay, and then here I would have 6 minus 7, the absolute value of negative 1 is 1. Okay, and then 7 minus 7 is 0, absolute value of that should be 0. And then 8 minus 7 is 1, the absolute value of 1 is 1, absolute value of 2 is 2. Okay, you don't have to write down that work when you're doing that in your homework, but I do want you to see it here. And of course, you can write it down. I just know that we can do some of that in our heads. That's okay. I just want you to have your table. So as you're creating your graph, we're going to start with 7, 0. And then I have 8, 1 and 6, 1. I have 9, 2 and 7, 2. And then, 5, 2. And then we're going to span our graph. Okay. So on the right side, we're going up here. And then on this side, you're going to use your straight edge to extend that. Okay, so you're going to span the grid that is given. So I'm going to give you some graph paper today, okay? So even though it doesn't look symmetric here, remember, if I were to adjust the window, I would see more of this side and I would see that full V shape. Okay, we're just looking at one part of the graph here. And then step 3 is to identify your domain and your range. So negative infinity to positive infinity is the domain. So it's going to be all real numbers. Anytime you do the absolute value, okay, and it's only the absolute value, it's not like a piecewise, you should have all real numbers for your domain. Okay, your range is going to vary. So when you're deciding on that, just look at your lowest point. What's your lowest y value? 0. And it goes to infinity, or you can just say, hey, all the points are above 0, so that's y is greater than or equal to 0. Okay, so for part B, we're going to do those same steps. So when we're finding the center, now we have more things on the outside. The only thing that's inside the absolute value is what? Yeah, the 4x. So we're going to take 4x, we're going to set it equal to 0. Okay, we would divide both sides by 4, which would give us 0. So then our next step is going to be to put that in the middle. Once you know what goes in the middle, we're just going to go 2 up. We're going to go 2 down, and then we're going to plug that in to find our y's. Okay, so this is a negative, and then here, 4 times negative 2 is negative 8 minus 1. We know that this is going to be a positive 8, but see how you have the negative 1 on the outside, the negative? You have to multiply those together. So a negative times 8 is negative 8. Negative 8 minus 1 is negative 9. Okay, so I have the negative on the outside. I have negative 4 inside minus 1. Okay, so again, you do the absolute value first, which is 4. You apply the negative, and then you subtract 1. Okay, for this one, it would just be the absolute value of 0. You multiply that by a negative, it's just 0. 0 minus 1, negative 1. If this is really the center, you should notice that the numbers are going to repeat themselves. So you have negative 1 times 4 is 4 minus 1. So that will give you negative 5. 2 times 4 is 8. The absolute value of 8 is that. Apply the negative, subtract 1, negative 9. Okay, in the center is always going to be your vertex. Okay, so this is your vertex here. 7, 0 is your vertex. Okay, this is what our vertex was for the first one. So when I'm graphing this, I like to start with my vertex at 0, negative 1. And then I have negative 1, negative 5. And then I have 1, negative 5. I know they're symmetric, so often I'll just do each one, 1, 2. Okay, and then we're going to use our straight edge to do each side. So notice that this is pointing downward because there was a reflection here. Okay, it's also narrower than what we had before. Okay, there is a horizontal compression, and then it moved down 1. And then don't forget to do your domain and range. Okay, so your domain is still going to be all real numbers. Okay, it's going to the left and it's going to the right, to negative infinity and infinity. Okay, that your domain should always be all real numbers for absolute value. And then your y, the lowest point is negative infinity, the highest is negative 1. Okay, all of the points are below negative 1. So it's going to be, it's less than or equal to negative 1 here. Okay, so you have some time to start your 1-6 homework. Hey, keep in mind that you have to make sure that you're submitting your homework before 7:40 a.m. No, 7.